This is an Algebra 1 video, Chapter 2, Section 9. It is the last section of the chapter, and hopefully the most fun. But anywho, I say that hopefully it's a lot of fun. It is word problems, and I know how you guys sometimes feel about word problems, but hopefully we can try to break these down as easily as possible. The lesson today is called weighted averages. And basically, the weighted average of data is found by multiplying each data value by the weight and then finding the average of the new data. We know what average is. You take up all of your items and divide by how many there are. But when something is weighted, it means that one of the items has a different, weight, a different cost, a different percent that's attached to it. So you can't just add them up and divide by how many there are. You have to first multiply the value by what its weight is. And so that might not make a lot of sense, and I apologize for that, but I'm going to hopefully try to explain that to you as we go through each of the problems. It'll probably be easier that way. So here we have an example. A tea company sells blended tea for $25 per pound. To make blackberry tea, dried blackberries that cost $10.50, and I should have put per pound there, sorry, that cost $10.50 per pound are blended with black tea that costs $35 per pound. So you can already see that in order to make this tea, you have to use two different components. But each component is not weighted equally. And in this case, the weight being the cost. The dried blackberries are $10.50 per pound, while the black tea is $35 per pound. So they have different weights. One is definitely more expensive than the other. How many pounds of black tea should be added to 5 pounds of dried blackberries to make blackberry tea? Okay, so what we're going to do is we're going to basically, in your book, you will notice that they might have a chart that you can use. I personally don't like charts. They seem like they're really complicated for me to draw out and all that kind of thing. But if you are liking the chart, then I encourage you to go to the book and look at those charts. For me, I like it to be just set up kind of in a sentence, so to speak. So I will explain to you what I mean by that. I know that I have two items that I have to put together, basically. I have an item plus another item, and hopefully it's going to get me what I want. So for example, I need some blackberry tea. Sorry, I need some, to make blackberry tea, I need dried blackberries. So I'm going to put DB, dried blackberries, and I also need black tea. So I'm going to use these abbreviations here, black tea. But every time I want to use dried blackberries, I'm going to have to pay for them $10.50 per pound. So the amount of dried blackberries times $10.50, and then plus the amount, and I'll abbreviate amount AMT, the amount of black tea that's going to cost me $35 per pound. And I want to know how many pounds of black tea should be added to 5 pounds of dried blackberries to make blackberry tea. So in the end, I'm going to have this blackberry tea combination, okay? So I'm going to have an amount of blackberry tea, all right, times 25, okay? So I want to go back to what we have here. Basically, I am going to have $25 per pound of blackberry tea, but to get that, I'm going to have to pay $35 per pound for a certain amount of black tea, and I'm also going to have to pay $10.50 per pound for a certain amount of dried blackberries. Now, if we read the problem again, we can actually start filling in some of our equation here, because the amount of dried blackberries is given. We were told that we are going to add to 5 pounds of dried blackberries. So as far as the amount of dried blackberries, that's just going to be 5. So it's 5 times $10.50 and we're going to add that to the amount of black tea. But you'll notice it says, how many pounds of black tea? And we've said before that whenever they ask a question like that, how many of something, that's pretty much the huge indicator that that's going to be our variable. So how many pounds of black tea? We don't know how many pounds of black tea. So the amount of black tea is going to be X times 35, and then equals the amount of blackberry tea times 25. Okay, so what is the amount of blackberry tea? Well, it's going to be the 5 pounds that we already have of dried blackberries plus the X amount of black tea. So it's going to be 5 plus X. And pretty much that is our equation. So to solve this, I'm going to have to get creative here because I'm running out of space very quickly. But I'm going to come up here to the top and I'm going to go ahead and grab my calculator here. And we know here that 5 times 1050 is going to be 5250. So over here I'm going to put 5250, and I apologize for bouncing all over the board here. I don't have a lot of space. X times 35 is 35x. And then we're going to have 25. And here don't forget that you have to distribute 25 times 5, which is 125. So it's going to equal 125. And then plus 25 times x, which is plus 25x. So this is our equation. Okay? So now we're going to solve for x. And I'm just going to bring these 25x's to this side. And at the same time, we're going to take this 5250 and move it to the other side. All right? So 5250 minus 5250, it's going to cancel. 35 minus 25 is 10. So we're going to get 10x equals 125 minus 5250. And we're going to have 7250. That, of course, 25x minus 25 is going to cancel. We divide by 10, which really just means to move your decimal over 1 unit to the left. But it all costs here, x equals $7.25 pounds. Remember that x was the amount of black tea that we needed to add to 5 pounds. So what we're saying here is that if you take 5 pounds of dried blackberries and add it to 7.25 pounds of black tea, then you will have 12.25 pounds of blackberry tea, which you can then sell for $25 a pound. And that is how we solve that equation. But again, you can see what I meant about weighted averages. Each item does not have the same cost, so one is definitely more expensive than the other, and that's what we mean by weight. So now we'll have you try this example. Just want you to know that my little diagrams over here, there are 3 types of coffee beans. There's premium, supreme, and blend. The premium is $9.50 a pound, supreme is $11.75 a pound, and the blended is $10 per pound. And you can do this problem here. So, another example of a type of weighted average problem is example 2. Mrs. Matthews has 16 cups of punch that is 3% pineapple juice. That's the weight, it's 3% pineapple juice. She also has a punch that is 33% pineapple juice. Again, not the same weight. How many cups of the 33% will she need to add to the 3% so that at the end of the day she has 20%? So you're going to take a 3% pineapple juice punch and add that to a 33% pineapple juice punch, and then hopefully when you mix the two, because one is stronger than the other, you'll end up with a mix that's only 20% pineapple juice. So it's a very similar situation from like we had before. So what we want to do is we have a certain amount of 3% that we want to add to a certain amount of 33%, and hopefully at the end of the day we're going to have a 20% pineapple juice. Well, the first thing we want to do is convert these percentages to actual decimals. So we're going to go 0.03 times something. The percent is going to be times the amount. So here we have amount, here we're going to have an amount, but they're not the same amount. So amount 1, amount 2 maybe. okay? And then eventually you want a 20% solution of both amounts combined. So we know for the 3% that she has 16 cups of punch, that's 3%. So 16 cups times 0.03 is the amount of 3% juice that she has. And she's going to add that, and it says here how many cups of the 33% punch. So how many cups of the 33%, so we don't know that. So that's going to be our variable. Call that x. So we're going to have 0.33x because 33% is 0.33. So we'll have 0.33x. And then we're going to end up with a 20% solution, and 20% is 0.2. But at this point, we're going to add the two amounts together. The amount of the 3% is 16. The amount of the 33% is unknown, so x. And there we go. And now we've set up our second problem. So now to solve this guy, we are going to go 0.03 times 16, which is 0.48, plus 0.33x. And again, we're going to not forget to distribute here. 0.2 times 16 is 3.2. And then 0.2 times x is 0.2x. Then we want to combine all of our x's and whatnots. So we're going to go minus 0.2x, minus 0.2x. At the same time, we want to get our minus 0.48 over here to this side, minus 0.48. Okay? So the 0.48 minus 0.48, they're going to cancel. But 0.33, don't forget with the points like I just did, 0.33 minus 0.2 is 0.13. And over here, 3.2 minus 0.48 is 2.72. And then, of course, the 0.2x and the negative 0.2x cancel. So I divide by 0.13. Barely have enough space there. Divide by 0.13. And it turns out that x equals 2.72 divided by 0.13, which is 20.92. 20.92. All right, so remember the question was, how many cups of the 33% punch will she need to add to the 3% punch to obtain a punch that is 20% pineapple juice? And the answer would be that she needs approximately 20.9 or almost 21 cups of the 33% added to the added to the 16 cups of 3%, and then she'll have a 20% pineapple juice combination. All right, so again, we'll let you try this one, talking about still percentages, a different storyline here, but same idea. We've got different types of antifreeze as opposed to punches, but one type of antifreeze is 40%, another one is 60%. So again, the question is, how should we mix each kind so that we can get the right combination of 48% at the end of the day. So now we're going to move on to another application, which is distance. So before we get started here, I want to remind you that distance equals rate times time. And that's going to help us for example 3 and example 4. So just FYI, distance equals rate times time. And so let's read this problem. It says, it took Travis and Tony 40 minutes to skate 5 miles. The return trip took them 30 minutes. What was their average speed for the trip? And usually when we do rate speed, which is, speed is the same thing as rate, so that's our rate right there. But we can also see from the problem that the distance is given in miles. And usually when we have miles, we talk about miles per hour, not miles per minute. So one of the first things that we have to do is to take our 40 minutes and convert them into hours. Okay, 40 minutes is basically 2/3 of an hour. So we're going to put 2/3 hour. And 30 minutes is a half an hour. So we're going to go 1/2 hour there. And that'll help us there. So again, if you're wondering how I did that, we learned in the last section 40 minutes and I want to convert it to hours, and we know that there's 60 minutes in an hour, so 60 minutes to 1 hour, the minutes on the bottom because I want the minutes to cancel, and then I get 40 divided by 60, which is the same thing as 4 over 6, but 2 goes into 4 2 times, and 2 goes into 6 3 times, and hence the 2/3 hour. So just I did the same thing with 30 minutes. The 30 minutes is a lot easier to do because we all already know that 30 minutes is half an hour. But anyway, just so that you were wondering, if you were wondering how I did that, that's how I did that. So let's go back to the problem. It says, what was their average speed? To get their average speed, we have to take both of their speeds, add them together, and divide by 2. So we have two scenarios. We have the rate that they go to, they are, so whatever, I don't know where they're going, doesn't really tell us where they're going, but they're going to somewhere. And then we have their return trip. Okay, so we need two expressions here, two different rates. Well, first of all, we need to know the rate on the way there and the rate on the way back. Now, we learned in the last section also, I think it was the last section or a couple sections ago, how to take an equation that's got multiple variables, and in this case, we want r, because I want the rate. So if I want to solve for r, I can divide by t on both sides. So r equals distance divided by time. R equals distance divided by time. All right, so now we can plug in what we know from the problem. We know that the distance is 5 miles, and that's going to be the case for both trips because the distance to get there and to get back should be the same, unless we're allowing for teleportation, which we're not. Then the place is not going to move, so your distance to and from should be the same. So in both cases, we're going to get 5 miles, but our time is different. In the case of the way there, we only took 2/3 of an hour. In the case of the return trip, we only took half an hour. Okay? So right now, what you should do, especially if you're like deathly afraid of fractions, is take your calculator, and I just want to remind you that if you're going to use a calculator, you want to take 5 and then the division button, and you want to definitely make sure that you put this little fraction in parentheses, otherwise you're going to get the wrong answer. So I'm going to put a parenthesis, 2 divided by 3, close parenthesis, and then I get 7.5. That is my rate, 7.5 miles per hour. Over here, do the same thing. I'll take 5 divided by parenthesis, 1 divided by 2, close parenthesis, and you get 10. All right, so if you try that whole parenthesis thing, and you didn't get 10 or you didn't get 7.5, then you didn't put it in the calculator right. But those are the answers that you should get. So now I know what the speed was for each trip, but the question was asking about the average. So the average, like I said earlier, is take the two different rates, add them together, so 7.5 plus 10, and then divide by 2. So 7.5 plus 10 is 17.5, and then divide that by 2, their average rate, or their average speed, was 8.75 miles per hour. And that is how we answer that question. All right, so let's see. Now we will go on to the next little guy, and this is your do-it-yourself question. Again, it's talking about average speed, so it's the same idea right here, average speed. And then we have one last example to do, which is example 4. 2 trains are 550 miles apart. So the easiest thing to do right here, before I even go any further, is just draw a diagram. So here is train A is traveling east. So this will be train A going this way. And then over here somewhere is train B, and he's going that way. Okay? So it says here that 2 trains are 550 miles apart. 550. So the distance that they're apart is 550. But they are heading toward each other on parallel tracks. So they're not on the same track because Lord knows that we don't want those trains to crash, okay? But they're on separate tracks, but they're they're parallel to each other. So here we go. It says train A is traveling east Okay, so that's why we have it going to the right. It's traveling east at 35 miles per hour. And then while train B, which is over there on that side, is traveling west. So east and west are opposite directions. So honestly, it doesn't matter which one you put east or west. It just matters they're going opposite directions. Okay, so just, beware. So it says that train A is traveling east at 35 miles per hour. So this little guy is 35 miles per hour. Meanwhile, the other train, train B, is traveling a little faster at 45 miles per hour. All right? When will the trains pass each other? Okay? So basically, again, this is a distance equals rate times time problem. So we know that for train A, the distance that train A travels is the rate, which train A's rate is 35, times t, the time. We don't know the time. That's why it says when will the trains pass it. When is a time question. So train A's distance is 35t. Train B, its distance is very similar, only it's not going as slow. It's 45t. Okay, now both trains are going towards each other at the same time. So one is obviously going to travel farther than the other. That's another thing to keep in mind. They are not going to go the same distance. If they were going the same distance, then they would meet in the middle. But clearly train B is going faster, so train B is going to cover more distance. For example, train B might travel all the way to here, a little over half, and train A has less to go because train A is going slower. Just so you have an idea. But what we do know is that whatever distance train A is going and whatever distance train B is going, when you combine those two distances, they should equal 550 because that's how far apart they are. So our equation will look like this. 35t, which is the distance of train A, plus 45t, which is the distance of train B, is going to equal 550, the total distance between the two trains. 45 and 35 is 80. Divide by 80, and we have our time. Time is equal to 550, and let me just write this down here, 550 divided by 80, which is 6.875. 6.875 hours. So after 6.875 hours, then the train can pass each other. All right? So, and if you want, you can even convert that into like hours and minutes, but that's okay. This is fine. So 6.875 hours. So now you can try a similar problem with these cyclists. And once you have done this example, you will have completed your notes for this lesson. And I will see you in class. And thank you for watching.